because I want to take a very critical look at what's happening in our environment. I went ahead while you guys were off camera. I removed the configuration on Cat 1 and I went in and removed the configuration on R1 so it's not generating BPDUs. Right now what I want to look at is I want to look at another notion, and that's going to be this idea of how we're going to be first protecting ourselves. And the first option was BPDU guard. The second option was BPDU filter. Now, when we do BPDU guard or BPDU filter, we can do it globally based on how we've got our port fast configurations configured, or I can do it individually under the interface. I think possibly I need to look at that first before we cut over to doing anything else. But when we access our system and we go in and take a look at, say for instance, interface, let's take a look at the ones that are running our bridging. So show spanning tree, VLAN 1. Now let's pick an interface here. All right, the interface I'm going to play with is not going to be FA01. What we'll do is we'll configure it for 19. All right, now when it comes time to look at 19, show run interface FA019, show run interface or show spanning tree, VLAN 1 interface FAO19. All right, so I can even come in here and say detail. Now, what we see here is some information that I want to make certain that we go through. So on port 21, which is actually port 19, and this should make perfect sense because what we have to recognize is this is a Catalyst 3560, which has 24 fast Ethernet ports, and it has 2 gigabit Ethernet ports. So what we're doing here is that our calculation is always going to be +2. So if I'm on the 19th port, it's going to be +2, so it's going to be 19, 20, 21. That's going to be the designator that the system is going to use to recognize my port because it puts the gigabit interfaces first. Now looking at this, we see some information. What I want to look at right now is going to be the idea of this concept with regard to how we're going to be communicating with the distant end. So right now I'm on Cat 1. And Cat 1 is the root bridge. At least it should be. 4097, yes I think it is, designated path cost. Here's what I want to talk about right now. I want to talk about the designated path cost. The designated path cost is the value that's being reported to me by my neighbor, which is its cost to reach the bridge. The root. Now since this is the root, then that value is going to be 0. So to illustrate that point, I want to go over to one of our other devices. So let's go over to Cat 2 and take a look at the output here. So first of all, we'll pick port 20 GIO1. So here we'll say show spanning tree VLAN 1 interface GIO1 detail. And let's take a look and see what we've got here. Now notice we have this value that I'm talking about, designated path cost. Still 1, I mean 0, because it is the root bridge. Now when we go in, right now the way we've got our current topology set up, we've got Cat 1, we've got it is the root, and then we have the radial connections down to Cat 2, to Cat 4, and to Cat 3. So what I'm going to do is I'm going to go over here to Cat 4 and I'm going to make Cat 4 the root bridge. Now in doing so, first of all I think I need to remove any config I have here. So show run section priority. No, it's a switch. Include priority. 4096, nope, I can actually come down here and just pick VLAN 1. So config T, spanning tree for VLAN 1, priority 0. The question is William's asking, does spanning tree use the SFP algorithm? No, it doesn't. What it does is it uses a graph computation based on those bids, but there is no maintained database. That's one of the problems with spanning tree. If it used the SPF algorithm, it would rely on that and be able to create a database. But no, it doesn't use the SPF. It doesn't use Dijkstra's algorithm at all. Maybe loosely based on it. It depends on what Radia Perlman and that bunch did. But inside the context of our discussions, no. So do show spanning tree for VLAN 1. We are now the root. So now that we're the root, what we're going to find is that I'm going to have computational values to get to that particular device. So I'm going to follow this track right here. I'm going to follow Cat3 to Cat1 to Cat4. So that's going to be this link right here. So we'll start from here. We'll start from Cat1. So let's go over to, Cat4, and take a look at the values that we see here. So exit. So I'm going to say show spanning tree for VLAN 1 interface FAO 19 detail. Now, just like we said here, notice we have a designated path cost of 0. We take that path cost and we're going to add it to our own cost locally, and that's going to give us the value here of 2. So 0 plus 2 equals 2. Now let's cut over to Cat1. Show CDP neighbors. Let's see, to get to Cat4, it's going to be 20. I thought I disabled that. No. Error, disable, recovery. That's going to force me to do the whole thing. Cause, let me remove this, guys, I'm sorry. BPDU guard. Do show run, pipe include, error disable. All right, that's now gone. Let me double check this from R1. Show run interface G01. And it's not there. I don't know why it was constantly running. All right, but we wanted to look at this from Cat1. So show spanning tree. And if I remember correctly, it was what? It'll be 19. Show spanning tree VLAN 1 interface FAO 19 detail. Now when we look at this, let's see what we have now. Let's take a look at, we have a designated path cost of 0, and we're going to be adding to it our cost of 19. So when we look at the drawing up here, we've got 19 for this link. It's coming up. So R1 knows that its cost to reach Cat4 is going to be this idea of 19. So now what we want to do is we want to move down here and take a look at what Cat3 sees. So when we get to Cat3, what we do is we're going to look at, I think 19, show CDP neighbor. Actually no, do show spanning tree for VLAN 1. And we're going to have 21. So do show spanning tree VLAN 1 interface FAO 21 detail. Okay, now what we're doing now is we have the designated path. So the designated path cost that we're seeing here is the 19 that Cat1 sees to reach Cat4. So we're advertising that down with a designated cost of 19. So that's the information that we have and what it's going to cost us to reach this device. That's going to arrive, and then what is going to happen is Cat3 is going to look at this interface and it's going to add its own cost to it. So that cost is going to be 19. So what's going to end up happening here is my own path cost would be 19. So I would actually take 19 and 19 and I would create 38. And if I had another device down here, say Cat6, that's what I would report as my designated cost as 38. And then Cat6 in this scenario would take its cost, which would be 19, and add it to that, and then it would pass it on forward. And that would be how we register and we send everything down. The other thing that we want to look at here is notice that we have multiple links between our devices. So between Cat 1 and Cat 4, I have 2 links. So let's take a look at what those are. So on Cat 1, show spanning tree VLAN 1. Okay, that doesn't help me anything there. I need to know what I'm connected to. Show CDP neighbors to just discover my interconnections. So I know I'm connected to 4 on 19 and 20. So now what I want to do is I'm going to come back up here and execute the other command because I want to see exactly what's going on. So I'm going to say show spanning tree VLAN 1. And on 19 and 20, notice this is a root port. This is an alternate port. Notice this is blocking. Now an alternate port, we talked about designated ports. Designated ports lead away from the root bridge. Root ports lead towards the root bridge. Alternate ports are ports that we can use to replace the root port if we were to lose connectivity to it. So now we see 19 and 20, but notice what we did is we picked 19 as the root port. Now what I want to do is I want to find out why. So on Cat 1, when I look at this, I'm going to use that same command again. I'm going to do show spanning tree VLAN 1 interface FAO19, and I'm going to compare that using the detail command to the output of 20. So now looking at this, we have both of the ports that we have. We have port 19, port 21 and port 22, which is FAO 19 and 20. Let me grab my eraser and get rid of that garbage. All right, so now recognizing this, let's look at how we made our determination. So first of all, we look at cost. Cost 19, cost 19. So cost of 19, cost of 19. So the question here is why, if these are the same, now I need to have some kind of tiebreaker. Now, the rationale behind this is I need to take a look at priority now. So my port priority is 128. My port priority here is 128. So what's going to happen is since I have a port priority of 128 on both of these, what's going to end up happening is the tiebreaker ends up being the lower port number. Now, here's what we're going to look at. All right, right now, we know R4 is the root bridge. Now, if I want to be able to manipulate this process to where I want to pick, say, 20 over 19, I have 2 ways of doing it, and I have to do it from 2 different locations. If I want to make a change on Cat 1 itself to be able to manipulate this decision, all I've got to do is go to the interface in question and give it a lower cost. That's the main point here. Cost is a local decision. So let's do that. Let's cut over to Cat 1. And what I'm going to do is I'm going to go to interface 20 and I'm going to give it a lower cost. So I'm going to come in here, config T, interface FAO 20, and I'm going to say spanning tree, cost, and I'm going to assign it a cost of 1. Then what I'm going to do is I'm going to do show spanning tree VLAN 1, and let's see what happened on those links, if anything. Well, let's see. We've got 20 is now listening. Notice 21 is now forwarding. 20 says it's the, 19 is now the alternate since 19 and 20. So 19 is now the alternate, 20 is now the root. It's going through its listening and learning process. Let's see if it ultimately converges. Okay, 19 is now blocking and 20 is now forwarding. Exactly, the bridge IDs are the same, but Pablo, the reason I didn't mention the bridge ID is because both of these links lead to the same bridges, so the bridge ID is going to be the same for this end of the link. Yes. So all I did is I went to 20 and I made it a cost of 1. So now what ends up happening is 20 is now the root bridge, or the root port. Now let me pick another color. 20 is now the root port. This one is now what we're referring to as an alternate, and it's also blocking. Now, cost, I can only change cost on the idea of, or on the configuration of a local device. Now, the point is if I wanted to pick or change this, what I'm going to do is I'm going to remove the cost value that we configured. But before we do that, let's take a look at what happened here. So again, I want to do the output of the show 19 detail and the show 20 detail. And I will grab my eraser and we'll go back through this. So when we look at the output of these two values, what we see here is immediately we know we're going to the same switch. So the bridge ID is not going to be a problem. We're determining the links between two devices themselves. So since the bridge ID matches for both of these, since the actual root bridge itself or the bridge ID matches, that's not going to be an issue. Then the first thing we do is we look at cost. This one has a cost, let me see here, sorry. This one has a cost of 19, that's 21. This one has a cost of 1. Lower cost is automatically going to be the value. But what I want to do is I want to eliminate that command right now. So I'm going to come in here, config T. I'm going to say interface FAO 22, and I'm going to say no spanning tree